Hello, hello, hello. So we are back again. And last time, as we have seen, we have learned about what is a compiler, what is a programming, why we need to learn programming. ये चीज़ें हमने देखी थी last time. But this time, I have something new because as I was preparing for the next lecture or next session, you can say, that time I saw most of the folks are a bit confused about what is a programming and what is a coding. Are these two the same thing? क्या वो एक ही थाली के चड्डे बड्डे हैं या फिर something else? So just to figure these things out, I thought let's break this up using the things like algorithm, flowchart, and pseudocode. So let's just now try to understand and see क्या होता है. Okay. And by the way, if you're not able to understand, I would say रुको, we'll come to that point जहाँ पे you will be able to understand in a more better way. So I would say just go back, watch few seconds once again, try to fresh up, and नहीं समझ में आए, leave it for now, leave it. Just try to listen and note it down. कुछ अगर if you feel like कुछ important है नहीं है, whatever is comfortable for you, do those things, because at the end I'm just trying to build your memory, or you can say muscle memory, so that you can understand the process, why you need to learn to code, and what are the benefits once you learned how to code. And then I would say it will be much more easier for you to get into the DSA journey which I was taking ahead. Okay? So now, keeping all these things aside, let's get started. Okay, so now let's see the things that we want to understand to get a more better understanding what is a programming in detail, and then we'll jump to the differentiation between programming and coding. So let's understand these three formats. Let's say we want to write any kind of code. The first and foremost thing in this coding cycle, let's say, would be understanding the algorithm. Now, what is an algorithm? Let's break it down. So let's see what is an algorithm first. So let's say I want to build a sandwich again. The most famous example, sandwich. This time let me bake it little, make it little good. That is easy for you also to view, for me also to view. We all can enjoy the sandwich at the meantime. So here are some veggies should be green. These are the veggies, some sausages, some veggies. Okay, so this is a sandwich. Now, as I said, toasted. So toast, 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 toast. That's it. It looks so amazing, right? Now let's see the process that was required to build this sandwich first. Okay, so the step one was to get ingredients. Okay, so we get the ingredients, that is bread, veggies, sausages, then butter, toaster, knife, XYZ things. We get these ingredients. Okay. Once we get these ingredients, the next step would be to place the bread or slice the bread basically into two pieces. And then we have to get first piece half baked, and then apply the sausages, and then apply some veggies on top of that. Once we apply those veggies, what we'll do is we'll apply the other slice of the bread, and then we'll put it inside the toaster. And then once it's baked inside the toaster, we'll garnish it with little cheese if required, and some shave and all those things. And once we have these things ready, it'll be around 4, 5, around 10 to 12 steps, let's say. And once it's ready, we'll see this sandwich ready for us to eat, served in a plate. So now, as I've shown you, there were 12 steps, let's say. So these 12 steps which were there, can we see this is something like instructions to make this final product sandwich, right? So now, as you can see, this is the steps that we require to build this sandwich. So can we term it as an algorithm? Because algorithm, what it is, it's some plain simple English set of instructions. Now, once I've understood this, I wanted it for others. Let's say other who wants to eat sandwich, they should also know, right, how to build a sandwich. And writing this English thing makes us feel little boring. Boring as in like think yourself only. That is, whether it's you, me, or anyone inside the world, do they love to read after a certain period of time? Most of them might say yes, some might say no. But in general, won't you get bored to read this set of instructions? And won't seeing just the visuals might make you more mouth watering and more hungry to eat that sandwich as soon as possible in place of plain English? Just think, won't that? Right? It will. So if it will make it, then why not let's make this set of instructions into some diagrammatical format, or you can say like a flow chart. So what I can do is, currently it looks mostly like a, you can say, flow chart only, but just to make it more little simple, let me just rub it. Okay, so now as we want to build this flow chart, let's try to understand few things first before I jump to the start and all those things. I would say let's understand few things. So the first and foremost thing is, whenever you try to build a flowchart, let's make it little more generalized, more universal, so that everyone can start understand, not start, they understand and they can be acknowledged. I guess you might be hearing some raining sounds because it's raining heavily here. So just ignore that for now. I would try to make it as less as possible, but yeah, it's raining, so it's natural. Okay, coming back here. So now, as we can see that we don't have some standardized format, so let's make some in flowchart. Let's understand few terms. So whenever we want to start any diagram, the best thing would be to say start. It's easy for us to understand. That's the only thing. And whenever we want to stop it, we'll say stop. That's it. Now, in between, we'll show all the instructions with the arrows. And the next thing would be to get the ingredients. To define the ingredients, not to get it, to define it. So, to define the ingredients, we'll always resemble them inside this parallelogram, we can say. I hope I am saying the right structure. If not, just understand it as a kaju katli. Kaju katli. So, we'll have this set of ingredients, everything over here. Then, followed by that, we'll have all the set of instructions in the rectangular boxes. Okay, all of them. And once the dish is ready, the sandwich is ready, we'll display that sandwich again inside this parallelogram. Once the sandwich is ready, we'll display them again in the parallelogram. So, this complete process will be displayed like this, which is much more easier for us to understand. That is, the inputs and the outputs will be in the parallelogram. Start and stop will be in the oval shape, and the set of instructions would be in plain rectangular format. Okay, that's simple. That's universally easy for us to understand. So let's take this as the universal language. Now, why I'm saying let's take this, because this is the format of writing a flowchart. That's the only reason I said, like, let's take this, because what else can you take? If you take something else, you might lose your generalized or universal approach, because other developers won't be able to understand what you're trying to say. That's the only reason I said let's follow this predefined structures so that we can understand. Okay. So now, as we have understood what is a flow chart, what we will know is we have this ingredients over here, we have this output over here, we have some set of instructions. So now let's take this piece and try to formulate the similar algorithm and the flowchart structure with some simple, very simple math problem. I know math is a little boring sometimes, okay, but it's fine. Let's make it very simple. I swear it won't be tough at all. Let's see. What is 2 plus 3? 5, right? Yeah, I hope you might know. If not, then I'm sorry, I can't help you with maths, because that's the base ka bhi base. And so just go learn math. Okay, so let's see. So we have 2 plus 3 equal to 5. So to get this 2 plus 3 equal to 5, what things have we did in our mind? That is, we thought we'll need some numbers, or we have some numbers, let's say, in our mind. And now I wanted to do something like an addition. And the meaning of addition was to add the two numbers and get the sum, that is 5. And once we have that 5, that will be our output. So let's write it in some English format. First of all, what I will do is start, not start. We are writing algorithm, right? So we'll do is get two numbers. Next would be let two numbers be 2 and 3. Okay. And the next step would be add the two defined numbers. I know my handwriting is like a doctor's handwriting, but kindly please bear with me for this. Okay. Fourth, after we add the two numbers, what we'll get is the output. So what we'll do is display the output. Okay. So now once we have the number, that is our output displayed, that is 5, what we'll do is it's done. The steps which we have thought in our mind is completed and we have got the output. So we'll say our mind to stop. That's it. Nothing else. That's the thing. You can say it as a algorithm. Now what we'll do is we'll try to make it little visually appealing. You can say like a flowchart. We had this simple problem to add two numbers. So let's the basic structure. Anda, we'll have it as a start. Then followed by that we have set of inputs. So now as I was thinking, what I was doing is I was getting two numbers, but where I was storing those two numbers, I was storing in a mind. But to represent them on a pen and paper, what we can do is, because our mind was that time acting like a storage box, dabba, where we can put everything and nothing will happen. But in this pen and paper ka thing, we need to make sure that we have some variables that's easy for them to understand. So let's say we have defined A and B as a variable for our inputs, that is 2 and 3. And we need another variable to store our output, because in mind what we were doing was we were storing our output. So we have defined few variables, 2 for input, 1 for output. Next what we'll do is we will have assignments. So what we'll do is A equal to 2, B equal to 3. We have defined them. Now what we'll do is we'll perform an addition. Now the way I'm writing here C equal to A plus B is because what I'm doing is I'm getting the value of A plus B and trying to store it inside a variable. And in maths, basically over here, the best way would be to make sure that people would understand that you are storing the values which is present on the right hand side inside the left hand side variable. That's what basically equal to stands for. Okay, it's not like left side and right side are equal. We're not doing that here. We are storing the value from the right side into the left side. That's the reason we're using equal to over here. So now I know you might be like, kya bol raha hai equal to? We are not kids anymore. I know you're not kids, but even you're worse than that. Why? We'll come to that. So just hold your horses. So now as we have got that C equal to A plus B and we have got the answer, what we'll do is we'll display it. That is C equal to 5. And once that is done, our code is complete, or the thinking process, and then we stop it. Now this looks much more easy for us to understand, and make it little more understandable. We can add few couple of English words like define, display, add before these variables so that it looks understandable. Here we do assign. So these things will look more understandable, more approachable for us. So now we have understood the structures. This structure is termed as an algorithm. This one is termed as a flowchart. Okay. And now what we'll do is we'll try to minimize this flowchart into little code-like structures. Now, when you say little code-like structures, that doesn't mean we are writing codes. What we are doing here is very simple. Copied, and we'll come here, paste. Okay, so we have it over here. So now what we'll do is let's divide it little. Oh, yeah. And now let's see what this looks like when I say little, like a code structure. Okay, so It's again, we'll just copy these words from your start. Okay. So now when we say define, so let's make it a little more precise, because what we're defining these variables for our integer values. If we look over here, we are not having any float or something else. We're just having plain integers. So we can say int, because you're too lazy to say the complete word integer. So let's say it's a int a comma b comma c. That's it. And let's make ourselves understand that whenever we are ending any statement, currently we'll end it with a semicolon, because currently the things I'm just trying to explain will not make much sense for this part basically, but eventually when we move ahead we'll get to understand. So let's make some assumptions over here. Whenever we end any line, we'll say it's ending with a semicolon. Semicolon, semicolon, whatever you want to say it. And then when you want to assign them, simple way. A equal to 2, comma, B equal to 3, semicolon. Once you have defined and assigned it, next step would be to add. What we'll do is C equal to A plus B. Again, semicolon. And lastly, you want to display it, right? So C equal to 5. And once that is done, what we will do is stop. So now, does this look different? Apart from the structure, it's exactly almost the same things which we are trying to say. And if we try to look back to the main algorithm, this was plain English. We just took few things from here and there and just tried to resemble it in more better and understandable way and more clean way, so that no one gets confused, nor you, nor me, nor our systems. That's the easiest way we can say explain anything. And this easiest and simplest and cleanest approach is termed as your pseudo code, because it looks like a code. If you look over here carefully, what I have did here is I've tried to take an example that is a C++ programming language as an example, and I've just tried to make these things looks just similar to the way we'll be using it inside the code. And the easiest way to understand was just by assuming things for now. So now as you've assumed it and it's very simple and easy, I hope you might have get till this point. So if not, just drop me your comments and we'll try to make a more better version in the future, so that you can understand in more better and easiest way if needed. But apart from that, currently what I'm doing is just trying to give you just the gist what is actually happening. So now as we have understood that algorithm is basically a plain English, we convert that into some visual and visually appealing format that is termed as a flowchart. And that flowchart is later converted into some more simplified and most approachable way. And that approachable way is termed as your pseudo code. Once these things are achieved, it's easy for anyone to write the code in any language. And now, the way we will be writing the code is the part called as coding. Okay. In any language, let's say we took C++ programming, or C programming, or Python programming, or Java programming, any programming language. And the way we are writing the code in that languages is termed as coding. But the process which we took the simplest example, that is to add two numbers, only two numbers. And these two numbers were added, and then we got an output that is 5, and that was displayed to us on the screen. Because in mind, what we had did was we had visualized how the 5 looks. Yeah, this is 5. Yeah, I know it's funny, but yeah, this is how your mind processes. So just to make it more visually understandable on pen and paper, this is the way to show it. And once you have showed these things, you have understood. Now we'll write this code so that machines can easily compile it and get the input as zeros and ones, and then it can easily give us back the results in the language which we have talked to the machines in start. That is in a C++ language or Python, any language which we are trying to communicate to machines for now. The process where we were coding was separate, and the flow which we did from algorithm to flowchart to pseudocode to coding, and then getting the output which is displayed to the world later on. That thing, the process, this complete process is termed as programming. So I hope you might have got a gist what is a programming and what is coding. These two terms sound similar, but they aren't. So next time, whenever someone says कि coding and programming are the same terms, say tu pagal hai. Don't say it. You will get nicely अच्छा खासा, which then you will never be able to say anything. So just make your mind and then those folks also understand like, hey, bro, listen, the thing which you're trying to explain doesn't sounds what I have learned, what I have experienced till now. The reason was that the programming is the complete process which I follow from start till end to get the results to the complete world so that others can visualize and understand it in most easiest and visually appealing way. But coding is the part where we just need to explain the machines. It's not something that is related with programming at all. That's the simplest thing which anyone can do. And today's companies are not looking for coders, they are looking for programmers who can understand the process and make machines understand so that they can get more efficient results via AI. So that's the reason when people say, na, AI will eat your jobs. No, it won't. It will never be able to eat your jobs because the machines needs to understand by human itself. Okay. So that's all for the second part. Thank you for watching and see you next time.